Greetings, everyone. We're excited to present our paper, Semi-Supervised Semantic Depth Estimation using Symbiotic Transformer and NearFarMix Augmentation. It is collaboration between myself, MD Awsafur Rahman, and Dr. Shaikh and Fattah from Department of EEE at BUIT. Let's first understand what semantic depth estimation is. It refers to the process of estimating both depth and semantics from an image. Here, depth means estimating distance information for each pixel in a 2D image, and semantics involves classifying each pixel in a 2D image into a specific category. Both depth and semantics are widely used together in a wide range of fields. For instance, autonomous vehicle, augmented reality, virtual reality, and robot motion, because both of these features jointly can provide a better perception of the world. Moreover, due to the symbiotic relationship between depth and semantics, both tasks can enhance each other by sharing information. For example, depth can help semantics by adding 3D view to scenes, thus clarifying the spatial relations of similar objects at varying distances. On the other hand, semantics can help depth by providing object categories and boundaries, essentially facilitating consistent and sharp-edged depth. However, existing methods suffers from certain issues while performing joint depth estimation and semantic segmentation. For example, first, semantic label scarcity across datasets and dataset-dependent architecture. Second, limited symbiosis due to only sharing information within local context between both tasks, resulting from their convolutional approach. Finally, loss of object integrity, limited diversity, and limited control due to augmentation. In this work, we address previously mentioned issues with our following proposals. First, we propose semi-supervised dataset agnostic strategy to mitigate semantic label scarcity. Secondly, we introduce Symbiotic Transformer to resolve limited symbiosis by exchanging information between depth and semantics within both local and global context. Finally, we propose NearFarMix augmentation to tackle overfitting in both depth and semantic tasks while solving existing issues such as loss of object integrity, limited diversity, and limited control. Our proposed data-agnostic semi-supervised strategy utilizes a teacher and a student model for learning depth and semantics. In this approach, depth is learned in supervised manner from ground truth, and semantics is learned in a semi-supervised manner from pseudo-labels produced by the teacher. We utilize a pre-trained one-former model as a teacher and our proposed model with Symbiotic Transformer as a student. In this method, our teacher model maintains a fixed number of classes in semantic labels across datasets, ensuring a dataset-invariant architecture. Moreover, semi-supervised nature enables its application to datasets with only depth information without requiring semantic labels. Now let's have a look at the overview of our proposed architecture. First, the input image passes through the max-width encoder, where both local and global features are extracted with MBConv, read attention, block attention layers. Then these encoded features are processed with convolutional decoder comprising a CNN, upsampling and yellow, and a layer normalization layer. Finally, the decoded features are processed with the proposed DSS module, which produces the final depth and semantics, ensuring proper symbiosis. Let's dive deeper into how our proposed depth semantics symbiosis module, in short DSS module, works. First, the decoded features undergo individual processing through distinct neck blocks, generating independent depth and semantic features. Then these features are fed into Symbiotic Transformer for information sharing within both local and global contexts, resulting in depth-aware semantic and semantic-aware depth features. The Symbiotic Transformer, which is responsible for symbiosis, comprises of two transformers, depth-guided transformer and semantics-guided transformer, which are both instances of LGCAT but serve different purposes. One takes depth as the query and semantics as key value, while the other one does the opposite. Then the separate head blocks refine these mutually aware features, generating the final depth map and semantics mask. In our proposed local global cross attention transformer, in short LGCAT, firstly, features are partitions into local dense windows by block cross attention, enabling local symbiotic enrichment. Then grid cross attention partitions the resultant features into global sparse windows, facilitating global information sharing beyond limited receptive fields. Finally, Fuse MBCom enables inter-channel interaction while maintaining important properties. In cross-attention, the computation is similar to self-attention, except the query is taken from one task, while the key and values are taken from other. Our ablation study proves that the proposed DSS method considerably outperforms the other symbiotic approaches on KITTI and NYU datasets, as measured by different metrics. On the other hand, augmentations introduce additional challenges in joint depth and semantic tasks. For instance, popular augmentations such as rotation, shifting, shearing, zooming hurt the depth estimation task as it breaks the pixel to depth relation. Semantic-centric augmentations such as depth-mix, cut-mix suffers from loss of object integrity, lack of control, and lack of diversity, also hurting the depth estimation task. Depth-centric augmentation, on the other hand, like cut depth, GLP depth, enhances depth at the cost of semantic performance, resulting discontinuity and inconsistency. Our proposed NearFarMix augmentation addresses all previously mentioned issues. Let's see how it works. Given two inputs, each consisting of an image, a depth map, and a semantic mask, it performs thresholding on depth and various masking operations to generate four regions, namely pre-far, overlap, exclusive, and near. Then the overlap region is removed and exclusive region is filled using masking operations to combine with the pre-far region, resulting in the far region. Finally, the near and far region are added to produce the final augmented image, depth map, and semantic mask. Let's see some samples from our proposed NearFarMix augmentation on the NYU-V2 dataset. In these images, rectangular boxes emphasize the regions of interest. We can clearly notice that depth mix augmented images compromise object integrity and cannot produce diverse and controlled samples. On the other hand, our method shows its immunity to object integrity loss, and also due to its threshold parameter, it can generate both diverse and controlled samples. Furthermore, the NearFarMix augmented images, depth maps, and semantic labels also look very realistic, thus further affirming its effectiveness. We can also notice similar improvements of the proposed NearFarMix augmentation over existing depth mix augmentation on KITTI datasets, which further demonstrates its efficacy. Our ablation study confirms the proposed NearFarMix augmentation's quantitative superiority compared to other methods on both NYU-V2 and KITTI datasets. Now let's take a look at the qualitative results of our proposed method on the NYU-V2 dataset. In these images, rectangular boxes highlight the region of interest. It is evident that our proposed method produces superior results in depth tasks compared to the existing iDisk approach in terms of edge sharpness, object background contrast, the similarity between prediction and the ground truth, while simultaneously producing accurate semantic labels. Additionally, similar dominance of our proposed method can also be seen on the KITTI dataset, demonstrating the effectiveness of our approach. Furthermore, the quantitative comparison of our proposed method with existing approaches on NYU-V dataset shows total dominance of our approach across all metrics. Similar superiority can be observed from the quantitative comparison performed on the KITTI dataset, validating the efficacy of our approach over existing methods. With this, I conclude my presentation, and thank you everyone for your attention.